Welcome to the HACCP Academy. Today for the HACCP plan principle 2 and 3, we're going to take the hazard table from the last mix and we're actually going to establish critical control points and actually look at critical limits, all the theory behind it, so you have a deep understanding. I can't wait to get in and show you. Let's go. As I said before, if you haven't seen the HACCP plan intro or principle 1, you'll actually notice they are both up here for you to have a look at. Today, in principle 2, determine critical control points, we're going to define what a critical control point is, determining critical control points with decision trees, determining CCPs and some of those considerations, and examples of good CCPs. Then, with principle 3, establish critical limits, we're going to look at the definition, how to complete a hazard audit table, what makes a good critical limit, and let's go. So let's define a critical control point. It's basically a point, a step, or a procedure in the process which is essential that a control is applied to prevent, eliminate, or reduce a hazard to a safe level. Now it's time to introduce you to a CCP decision tree. The reason we have this is once we have the steps of production, we have to decide where the critical control points are going to sit. Now you'll notice here I have the process steps, hazard and control measures, and then here we have questions about the CCP. Now I'm going to refer to the decision tree. Question 1 is there a hazard at this step? And that is a yes. Then we move through to question 2. Do control measures exist for this hazard? I'd say no. It takes me around a loop, but eventually it says yes. Next, question 3. Is there a step designed to eliminate or reduce the hazard? At this point I say no. And that will take me through to the next 2 questions. And when you actually do this in class, you'll see that those last 2 questions for me is no. You need 3 or more yeses, and that establishes the critical control point. Some things to consider when determining critical control points. Are they going to be early or late in that particular process step? I'm going to give you an example. We have a allergen or a food poisoning bug that if it's caught early in that process, it will be successful. But if it's caught later, it won't work. Then finally, we have the later process where we had to splintered bones. Now, if we do that later, we can pick it up. But generally, most CCPs will be put later in the process step so they can pick up more than one of the critical areas that we need to keep the food safe. So while you're sitting there in front of your template, you go, well, I don't really know. Give me some examples. So let's start with an example. First is thermal destruction. So actually heating food over 60 degrees, normally about 70, to actually kill all of those microbes. The second is rapid cooling. Remember the 4-hour, 2-hour rule, defrosting, and actually bringing the food through the danger zone very quickly. The next is the addition of acid, and what this can do is reduce the pH level, which actually fosters more microbe growth. And finally, in some products, they can actually add a chemical preservative, which will actually allow it to last longer. That was principle 2. Now let's do principle 3, which is establish critical limits. So first of all, definition usually refers to a parameter that can be checked while a step is occurring so that if the limit is exceeded, effective corrective action can be taken straight away. Now we have to look at the difference between safe and unsafe. So anything that exceeds the critical limit is unsafe and is therefore not acceptable in the process, and we go back to the last step. Alright, like the CCPs, let's have a look at the types of critical limits. we have receiving temperatures, and example of that is 0 to 5 degrees. Time parameters for cooking. Example here, cook to 65 degree core temperature for a chicken roast for 5 minutes. Thermal destruction of microbes, cooking over 70, could be chemical testing, antibiotic testing, or physical checks for the presence of foreign objects. Now, I'll give you an example. The storage of raw chicken breast, which we've all done before. It must be stored at between 0 and 5 degrees as a critical limit. That critical limit must be there at the same at all times. So we actually set a maximum and a minimum, and if it goes above that, then it's contaminated and could be unsafe. Okay, for principle 3, we now go back to our template, which is here, which is a hazard audit table. You have to add the steps from the last step, so hazard and control measures to the table. Here's my table, and you'll recognize these 3 steps we have already done. And the monitoring procedures, this is a very clinical scientific process to say what, how, when, and who at all times. So with this example, we'll be monitoring temperature and the time for preparation of chicken. We'll do it via a temperature probe and a clock seeing the time. When we'll start and at the end of the preparation to make sure we've met the critical limit, and the food handler or chef. So the critical limits are explicit so that we can actually document it. When we start, it must be under 5 degrees as a storage, and while I'm preparing it, I have 20 minutes, and then I need to store it under 5 degrees very, very quickly. So there are many critical limits. What makes a good one? Let's have a look. It needs to be easily and rapidly measured, inexpensive, accurate and reproducible. It needs to be reinforced by validated data that's actually been put down. The measurement procedures need to be easy to teach and to remember. Remember, it's busy in a restaurant. We don't have the time for slow processes or scientific experiments. It's not going to happen in a restaurant. And remember that this is a clinical scientific approach to food safety, step by step, and is very effective. How time flies when you're having fun. We've done principle 1. In this mix, we've looked at principle 2 and 3. We now understand what a CCP is, how to actually apply it to the form. Then we looked at critical limits, good critical limits, and how to actually put it on the template. I hope you've enjoyed this mix. I look forward to seeing you next time at the HACCP Academy.